you talk to me, then I'll try to fill in the gaps.
Okay, so I did, I plugged in something really close to the 3 to find the left and right limits.
Let's write that down. I think part of the reason I'm writing it down is because when we do the written section of the test, you have to write out the limit statements in similar problems, otherwise they don't give you any points. So you're finding the left-hand limit, and what did that turn out to be?
9 plus b.
Or take the right-hand limit. And it's also critical that you know why you're finding the left and right limits. You remember why. Okay. So what you're doing is you're remembering that you've done another problem that's similar, which is really not the best approach because that's an easy way for them to fool you in some sort of new variation of a problem. So the thing to remember is they ask us to find A and B, so I ignore that. In fact, what I do is I try to, there tend to be what I call forward problems and reverse problems on the AP test. This is a reverse problem because they're telling you the function is differentiable, and then they're asking you to figure out A and B. The forward version of the problem would be show that the function is differentiable. And so that's where your memory has to say, oh yeah, that's right. In order for a function to be differentiable, it has to be continuous first. And so your flashcard memory is remembering this idea, that in order to be differentiable, the function must first be continuous. That leads to your flashcard memory, which says, oh yeah, function's only continuous if the limit from the left and the limit from the right are the same, as well as the value of the function at exactly 3 itself. This would be continuous at x equal 3. So it is critical that you remember the reason why, and it's critical that you have these 2 flashcards. Do you have this flashcard?
Yeah.
Okay, good. So that's where I find the limit. Back to here. So what's the right-hand limit, Josie?
27a.
Get to there?
And then they're supposed to equal each other?
Yes. In fact, I think it's good practice to say we should really make sure we know f of 3 as well. What would f of 3 be?
9 plus b is
Good. Yep. And you're right, because the function is differentiable, therefore the function is continuous, therefore all 3 of those must equal each other. So that gives us one equation that relates A and B. Doesn't tell us A and B, but at least we're closer. So keep going.
And then that's far they got, and then I just started plugging in the values
All
of the
right.
left to see.
Checking. So the next step would have been to say, okay, now that I've established that the function is differentiable at x equal 3, I need to check for differentiability itself, which means I need to check the limit from the left, the right, and the value in the middle of f prime. Giving myself a little more space here. See if the magic board will do what it's supposed to do. There we go. So do you have this flashcard as well?
Probably, yeah.
Okay. So do you know what to do? If you don't, it's okay. But do you know, like we've done this, that's what we did over here. But we're supposed to keep, again, it's the idea that if this were the forward version of the problem, we would be trying to prove that the function is differentiable at x equal 3. It's the reverse version, but we don't do it backwards. We just do the same thing as the forward version, hoping that we can find a and b. So we've got to do this. Do you know what to do this?
You just take the derivative of the limit.
Very good. Well, not the derivative of the limit. We want to take the derivative of the function. So we need to go find f prime. So do you know how to write the equation for f prime?
The first equation would be 3 plus b.
Close. B is a constant, so when we take the derivative of a constant all by itself, I'm going to get 0.
Oh, okay.
When I'm taking the derivative of a piecewise function, I don't ever want to use the equal sign until I know the function is differentiable. So I'm going to start with that, just so I remember that, oh yeah, I don't put the equal sign yet until I know the function is differentiable. But this problem is differentiable, so the equal sign is okay. So what goes here?
3x squared.
Times a.
No,
Because the a is just a multiplying constant, so we can just pull it out of the way and then take the derivative of x cubed, which would be 3x squared. Like that. That makes sense. So now we've got to go back to our flashcard and say, I have to show this now. So I've got to find the limit of f prime as x approaches 3 from the left. So what would that be, Chelsea?
just 3.
Yep. And then what would we do next? Say again.
27a.
Uh-huh. And for completeness, on the written section of the test, we better develop the habit of finding f prime of 3. Because the equal sign is here, yeah. It's 3. Makes sense? So now what?
So all those limits have to equal each other, right?
These 3 values must equal, therefore 3 must equal 27a. So now what?
So a equals 4.
Keep going.
And so then you can use that to solve the limit from the first one.
Right. So I can take this and plug it in here.
So that would be 9 plus b equals 9. Or equals 3.
Question?
Nothing makes sense.
Cool. The key to the problem really is recognizing that idea of a forward versus reverse problem, recognizing that because they're asking me to find constants, it's probably a reverse problem, and then recognizing the forward version of the problem would be just to show that the function is differentiable at 3, and that's basically what we did. We just showed that the function is differentiable at 3 as long as b has this value and as long as a has this value. So, it works. Please, Jay.
You said that we can't put the equals to 3. And I remember you saying that, but I don't remember why you did put it later.
Gotcha. So the idea is that when we have a piecewise function, there's a pretty strong possibility that the piecewise function will have a corner. It's actually fairly common. if the piecewise function has a corner at some point, we'll say x equal 3, that means I cannot find the value of the derivative of the function at x equal 3.
Yeah.
So this is our function f. F prime of 3 would be undefined. So when I'm writing the formula for f prime, the corner, if there is one, is going to occur at the junction of the two functions. So we had something like this. I can't remember what it was. So this is the formula which tells us how to find all f prime values. If the function has a corner, I can't find the derivative at the junction, so I can't be putting an equal sign here. Otherwise, I'd be claiming that at x equal 3, the derivative is 3. But if there's a corner, the derivative is undefined. That's why I can't have the equal sign. I don't know if that was a very good explanation.
Wait, so how, then you put it on later, so why did you,
Oh.
how'd you know to put it on later?
Perfect. In this problem, so the habit I want you to have is, hey, I'm finding a derivative of a piecewise function. I just want to automatically remember when I'm finding the derivative of a piecewise function, I've got to be cautious about putting the equal sign. So I start out by just remembering that habit. But then I think for a moment and say, no, wait a minute. This function f is already said to be differentiable, meaning you can find the slope at x equal 3, so it's okay to put the equal sign. It's the difference between a forward versus reverse problem. If it's a forward problem where you're supposed to show that the function is differentiable, you would not want to put the equal sign until you verify that there isn't a corner. You verify that there isn't a corner by finding those limits. So you find these two limits. If they truly do come out to be equal, then it's okay to add the equal sign. In this case, I knew they had to be equal because the function was already said to be differentiable. I don't know if that helped, though. It's a lot of words. Okay. Any other questions from either of you? Let's stop this. So we'll just take turns. Jacob, how can I help you?